Okay, so I'm going to give you guys a rundown of everything that you need to know for the test. So the first thing we're going to go through is the midpoint formula, and this should be pretty straightforward. So these next two are going to be from 9.1. So 9.1 we did midpoint formula, we also did distance formula. So I'm just going to give you two ordered pairs. So let's start with 5, 2 and 7, 8. So these formulas are super easy. They will work with whatever ordered pairs I give you, positive, negative, whatever. So let's first find the midpoint between them. So the midpoint is super easy. It's just going to end up being an ordered pair. And what you do is you take the two x values and you add them together. So you take x value plus x value and then divide by 2. Super easy. And then do the same thing with y's. Y value plus y value and then divide by 2. Okay, so no matter what the values are, that's what you're doing. You're doing x plus x and dividing by 2, y plus y and dividing by 2. And then your new ordered pair will be just whatever this simplifies down to. So 5 plus 7 is 12, and 12 divided by 2 is 6. 2 plus 8 is 10. 10 divided by 2 is 5. So that just means this is the coordinate point that's exactly halfway in between these 2 points. Okay, so now let's do the distance formula. I'm going to just keep using those same 2 points. So the distance formula is a little bit more complicated. You start with this big, huge square root, and then in parentheses, this time you subtract x value from x value. So we do x value minus x value, and then you square that quantity, plus, and then you do the same thing with the y values. Y value minus y value, and you square that. And this is under one big square root. So remember, because of this addition, this big square root can't just cancel out these squares. It doesn't work like that when you have addition. So let's simplify this up. We've got 7 minus 5, which is 2, and then 2 squared would be 4, plus 8 minus 2 is 6, and 6 squared would be 36. All right, so we add those together, we get the square root of 40. So you've got two options. Square root of 40, you could clean that up and just get a simplified square root for it. If you wanted to do that, you could take out the square root of 4, which would be 2, and you'd be left with the square root of 10. That's one way. If you want to leave your answers in terms of square roots, that's totally fine. Otherwise, let me show you. You can just plug in, and I don't have my graphing calculator at home, but you could just do square root of 40 and give me a decimal. So that would be 6.3. So whatever you prefer, square root version, decimal version, does not matter at all. Okay, so that's your 9.1 stuff. Just pretty straightforward formulas. So you're going to have one of each of those. And then we move on to 9.2. 9.2 is the parabola stuff. So you're going to have to do two different things with parabolas. First thing that I'm going to do is I'm going to give you something in vertex form. I'm going to give you something in standard form, I guess, general form, and you're going to have to put it into vertex form. So first you're going to have to transform an equation that looks something like this. Okay, so turning something like that into vertex form. So just so we know what we're going for, let me write the vertex form right underneath it so we kind of know where all the pieces are going to come from. So first of all, the y is just by itself, so it's going to remain by itself. Never should you do anything to that other side. We just want to leave that y by itself. So first thing is we look for that a. So a is going to be whatever number is right here. So that's -2. So we're going to start by factoring that -2 out, and then we're going to have a set of parentheses just like we have a set of parentheses here, and then see how we have just the constant hanging out on the end. We're just going to leave this constant hanging out on the end, so don't put anything else there. Okay, so now these two terms that are not the -33, see how we have that -2 on the outside, so we're going to factor out that -2, and then we're going to write the leftovers in parentheses. So divide this by -2, I'm left with x squared. Divide this by -2, I'm left with positive 8x. And then notice I'm purposely leaving a little space there because I need to have another number here so that I can write this in this form. And that's where we do that completing the square step. So we start with this number right here. It's 8, and we do two things to that number. First, we're going to cut it in half. So if I cut it in half, I get 4. And then if I square that 4, I get 16. Okay, so that step again, I'm cutting this number in half and then I'm squaring it, and that's the number I'm going to add right here. Okay, so now I just changed my equation by putting that number in there. So what I'm doing next is see these two. this actually gets distributed right here. So this is actually -2 times +16, which is a -32. So if I were to redistribute this -2, I would have a -32 that wasn't there before. So the way that I balance out a -32 that didn't used to be there is with a +32. Okay, so you add, you take it away, it's like it never happened, but obviously we need it to happen if we're going to try to transform it into this vertex form right there. So let's start rewriting. We've got y equals -2. This is going to factor down to x plus 4, x plus 4. So since there's two of them, I can just write it as x plus 4 squared, and these combine up to a -1. So now you can see I've got everything that I need to be in perfect vertex form. Okay, so that's the first thing you guys are going to have to do is write an equation in vertex form that used to be in this general or standard form. And then later on the test, you're going to have to graph that equation that you came up with. So let's practice graphing it right now. Okay, so when you graph parabolas, we're looking for 3 points. First point is what we call the vertex, and the vertex is always the h comma k from when you're in vertex form. So the h is this number, the k is this number, and then we're going to have 2 more points we're going to get by transforming these. So our parent function was just y equals x squared, just the simplest parabola that you can have, and these 2 points were on y equals x squared, but when we transform that function, it's going to transform the points. So let's start with our vertex up here. So we take these 2 numbers right here, but notice this is x minus h, so that means this is technically x minus -4. So we would have -4 as the x coordinate of our vertex, and then k would be -1. Okay, so that's our vertex. That's going to be the low point or the high point of our graph, depending on whether it flips right side up or upside down. And then we're going to transform these 2 points. Okay, so in the parentheses, I have an x plus 4. So what that means is that my entire graph is shifting 4 units to the left. Remember, with the x, it always does kind of the opposite of what it looks like it's going to do. So we're going to shift everything 4 units to the left, which means subtracting 4 from these values. So 1 minus 4 gives me a new x value of -3, and -1 minus 4 gives me a value of -5. So I've shifted those. Next, 2 things are going to happen to my y value. They're going to multiply by -2, which is going to flip it upside down and stretch it out, and then they're going to move down 1. So all my y values, I'm going to multiply by -2, and then subtract 1. So whatever number is here, you multiply. Whatever number is here, you add or subtract. So 1 times -2 is -2, minus 1 is -3. And same thing with this number. These values right here match, and so these values are going to match. So this also ends up being a -3. All right, so I have these 3 ordered pairs. All you do is you're going to set them up and plot them. And I'm going to give you guys a grid so that everything can actually be plotted accurately. So that way you don't have to worry about how you're spacing things out. So -4, -1 would be right there. And then we have -3, -3 there, and -5, -3 right there. So you've got these 3 points, and you're just going to connect the dots. Make sure it's a smooth and rounded parabola as much as you can. It's not that like V absolute value graph. It should be kind of smoothed out as you go through the parabola. So that's what it'll look like. Like you said, you'll have or like I said, you'll have a grid, and it'll make it a lot easier to graph it that way. All right, so that's 9-2. So you guys will have to do 2 things. Transform from this form into this form, and then graph. Okay, next section was 9-3. That's all about the circles. That's our next shape. Okay, so here's what you'll have to do with circles. I'm going to give you the center, and I'm going to give you the radius, and then you're going to have to come up with the equation. Okay, so it would say something like, write the equation of a circle with radius 3 and center at like 1, -5. You know, so I'll give you a radius, and then I'll give you an ordered pair for the center, and then you guys will come up with the equation. All right, so our equation looks like this. This is a standard form for a circle. Make sure you know that. Make sure you know where all the pieces fit. So our center, that's H and K, and then our radius is R right here. So when we plug this in, it would be x minus, and then h would be 1 squared, plus y minus, and k would be -5. So I'll change that to plus 5 minus a negative, equals 3 squared. So 3 squared would be 9. So for the first part of the question, that's your answer. Should be pretty straightforward if you know how to use this standard form. You just plug in the radius, plug in the center, you've got your equation. That would be your answer for the first circle question that I'm going to ask you. And then the next one will say to graph. So you'll come up with the equation, and then I'll ask you to graph that equation. So you're going to plot all of these features that we just came up with. Okay, so the center is +1, -5. So you'll make a little mark for your center. Remember, it's not an actual point. And then the radius is the square root of 9, which is 3. So that means you're going to go 3 units in each direction and leave a point there. Okay, so you've got 4 points. So all you do is you connect the dots and you make a circle. And remember, I will be giving you a grid, so it'll make your circles more accurate. All right, so that's 9-3. Those should be pretty straightforward if you know those standard forms. Next, we are going to move on to 9-4, which is our ellipses. That's the third out of 4 shapes. Okay, so here's the type of questions that you're going to see for an ellipse. I'm going to give you the vertices and the co-vertices, and then you are going to create the equation and then graph it. Okay, so the directions will say something like, or not graph, I guess. It'll be write the equation. So I'll give you 2 vertices. And 2 co-vertices. Okay, so there's a couple different ways that you guys could go about this. First way that I taught you was to plot these points, and then we can come up with the center ourselves. Second way is kind of just by almost just looking at it, which doesn't sound like a very accurate method, but I'll explain what I mean. So here's the standard form that we're going to have. We're going to have this. Okay, so when all is said and done, when all the pieces are plugged in, our equation should look like that. So we know we're going to have x minus something squared over some number squared. Same thing with y. And then we know there's going to be a 1 on the other side. So this is supposed to be the center. So here's a really, really easy way to find the center. Look at what the vertices have in common. Okay, so these are just going to be on a line. So if you plot this point and you plot this point, notice what they have in common. They both have a y value of 5. So these vertices are going to be on a horizontal line that both have a y value of 5. That horizontal line is going to run straight through the center. So if it runs straight through the center must also have a y value of 5. Okay, so we know that the y value of our center is 5. So we can plug that right in there. And then look at the co-vertices. These we know must be on a line, and we know the center is also going to be on that line. So if we have the point 6,1 and the point 6,9, they're going to be on a vertical line, up and down, and the center must also be on that line. So what that means is that the x-coordinate of the center is 6. So we can put a 6 right here. Okay, so it should be pretty easy to pick out what the center is. It's just basically what the 2 ordered pairs have in common. Okay, so now, next thing I want you to look at is the change in x. So here, this a squared, a is the distance between the x-coordinate of the center and the other x-coordinates. Let's take a look at this. Look at the difference between my coordinates. Come on, pen. Let's try this again. Take a look at the difference between these x-coordinates and these x-coordinates. All right, so these, how many units are these apart? How many units are these apart? So my graph is centered at 6. And then we go to the left to -2. So the difference between these 2 x values is 8 units. That means from the center, I'm going 8 units to the left. And then you can also see from the center, I'm going 8 units to the right. So 8 units left, 8 units right. That means this number should be 8 squared. So this is going to be 8 squared, which is 64. All right, like that. Next, I can look at the exact same thing, but with the y's. So we know that the y coordinates are centered at 5, and then you can see how far they went to their next points. So we were centered at 5, we went down to 1, centered at 5, went up to 9. So that's a 4-unit difference. 5 down to 1 is 4 units down. 5 up to 9 is 4 units up. So if we're going 4 units up and down, 4 squared is what you should have under here in this denominator. So 4 squared would be 16. So that's the first thing that you guys will be doing, is creating that equation. So that'll be the answer for one question. And then later on, I will tell you to graph that equation that you came up with. All right, so I'll tell you to graph, and that'll look something like this. So 6, oops, not down. Should be going in the other direction. Let's try this again. All right. Sorry, more like that. All right, so make a little mark there. So that would be 6 units, 5 units, so that would be the center. And then we know we're going 8 units left and right. Okay, so we have a point right there. And then left, 6 units would take us back here, and then 2 more, like right there. So 8 units left and right. And then square root of 16 is 4, so I know I'm going 4 units up and down. So it's 4 units down and 4 units up. Okay, so we plot those 4 points and we just connect the dots. Okay, and that would be your ellipse. Another way that you could have come up with the equation is you could have just plotted these 4 points. So you've got -2, 5, that's right there. You've got 6, 1, which is right here. You have 14, 5, which is right here, and 6, 9, which is right here. So you could have just plotted those 4 points that were given to you, and then to figure out the center and how many units apart and everything like that. For the center, you could have connected these dots and connected these dots, and then right where these axes intersected, that would have been your center. So if you had plotted these points first, you could have counted this out and said like, all right, 6 units, 5 units, the center must be 6, 5, and then you could have counted out the 8 units to the left and the right and up and down 4 units, and then you could have created the equation that way. So either way, if just like looking at the points doesn't work for you, just sketch out the points, do this, find your center, and then literally count it out left, right, up, and down to figure out what your numbers in the denominator would be here. Okay, so that's 9-4. Last shape we've got is the hyperbola from 9-5. Okay, so with the hyperbola, you guys will be converting it into standard form using completing the square. So this one's going to be a little bit more complicated. So you're going to have an equation that will look a little bit crazy, not at all like a hyperbola, and it's going to be your job to get it into standard form. Okay. So here's what we do with these. We start grouping terms together. So you're going to group up all the x stuff together, group up all the y stuff together, and then any constants that you have are going to get pushed off to the other side. All right, so since we started with our y stuff, we're going to group our y terms together. So put those together first. We're going to make a little group of y stuff, and then make a little group of x stuff. Okay, so there's a group of x stuff. And then if you have a constant, you're going to move it over to the other side if it's not there already. So I'm going to subtract 585 from both sides. So our setup will initially look like this. All right, next thing we're going to do is if there is some sort of term that's in front of the x squared or in front of the y squared, we're going to factor that term out. All right, so with the y's, I have an 81. With the x's, I have a -16. So you're going to start by factoring that term out of both of those other terms. So these ones, I'm going to factor out an 81, and then you're going to leave the leftovers in parentheses. Here I'm going to factor out, whoops, that should be squared. Factor out a -16, leave the leftovers in parentheses, and then that -585 is just going to hang out on the other side of the equation there. So here when I divide these both by 81, this is just a y squared. This will be a -10y. Leave a space so we can complete the square. Here, divide by -16. This will be just an x squared. This will be a -6x. Again, leave a space because we're going to complete the square. So here's what this will look like. Right here, I start with my -10. And my -10, I cut it in half to get -5. And then square that to get 25. So this is plus 25. So this is the part that people have a hard time with and that people end up forgetting about. Remember, when I multiplied or when I added in this 25, this is really 25 times 81, which is going to be a big number, but that's the number that I should be balancing on the other side of the equation. So let me type in 81 times 25 is 2025. So you should also be adding 2025 to the other side of the equation. And that was just 81 times 25. All right, next, complete the square here. Half of -6 is -3. Square that, we get +9. And then this, remember, is what we need to balance on the other side. So we have 9 times -16, which is -144. So you'd also subtract that 144 from the other side of the equation. Okay, so we're trying to keep the balance. We're going to combine up all these numbers. So this is now 81 out front. This will factor down. So this will be y minus 5, y minus 5. So write it as y minus 5 squared. -16 right here. This factors to x minus 3, x minus 3. Equals, I'm going to type all this in. All right, so we have -585 plus 2025 minus 144. And that ends up being 1,296. Big numbers here. The very last thing you're going to do with the hyperbola, you're used to this just being a 1. So we're going to divide everything by 1296. And then once we do that, it'll be in like the normal form for hyperbola. Okay, so this 81 over 1296. 1296 is divisible by 81. It leaves us with a 16 in the denominator. Okay, and then this is also divisible by 16. That means it leaves us with an 81 in the denominator. So that is our hyperbola in standard form. So again, you'll do one question where I'm just telling you to get it into standard form. So this would be your answer. And then later in the test, I will tell you to graph that hyperbola. All right, so that's what we're going to do right now. Just practice graphing. So you've got the equation right in front of you. So here's what we're going to do. We're going to identify what the center is. So our center, be careful here. Notice, even though the y is written first, we still write the x coordinate first. So +3 and then +5 for our center. We are going to go left and right according with our x. X tells us how far left and right. Square root of 81 would be 9 units. We're going to go up and down according to what our y tells us. Square root of 16 would be 4 units. And then last thing we need to know is that according to this y being first, our hyperbola is going to open up and down like this. Okay, so it's going to be a shape like that because we technically have two different hyperbolas. We've got up and down if the y is first, or if these were swapped and the x was first, then it would open left and right. So we're going to plot all this stuff. So a little center there. So we're going to go left and right 9 units. One point right there. And point right there. So that's left and right 9 units, and then up and down 4. Right there. Okay, so here's what we do with the hyperbola. You make those 4 points, and then from those 4 points, we're going to make this dashed box. And that's going to tell us exactly how wide or how narrow our hyperbola is going to be. Okay, so make the box, and then with the box, we are going to go with this diagonal X that goes through the corners, through the center, and out the other side. We're going to do another one in the other direction. Okay, like that. And then once all that is sketched in, we do the actual hyperbola, so we know it goes up and down. So it's going to go through this point and through this point. So it just kind of goes right along those diagonal lines, right through the vertex, and then back along the diagonal lines. So this one's going to be super wide. That's just because that dotted X is super wide. So it'll look something like that. The bottom one was not great. It should look kind of like that, going right along those lines. All right, so that would be graphing a hyperbola. So that's everything. 9.2 through 9.5 are your main shapes that we're learning how to graph. All right, next thing we're going to do is from 9.6, something called the discriminant, and that tells you how to identify what shape something is just by looking at the equation in standard form. Okay, so we're going to have 3 different things. Here's your standard form right here. Okay, so when you're in standard form, we're looking for something called the discriminant. And the discriminant is b squared minus 4ac. So b is whatever's in front of the xy, a is in front of the x squared, c is in front of the y squared. If ever you don't have one of those terms, you just plug it in as 0. So what you're going to do is you're going to calculate this, and I'll tell you, you'll see the phrase, use the discriminant. So that number is going to come out to be one of 3 things. Either it's going to be positive, it's going to be exactly equal to 0, or it's going to be less than 0. Okay, so if it comes out greater than 0, that means it's a hyperbola. If it comes out exactly equal to 0, that means it's a parabola. And if it comes out less than 0, that means it's an ellipse. So be careful with the ellipse, because an ellipse might also be a circle, which is like a more specific version of an ellipse. If these 2 things are true, if the discriminant is negative and b comes out to be equal to 0 and a comes out to be equal to c, then it's a circle. Okay, so circle technically is still an ellipse, so it does fall in this category, but if those 2 things are true, then more specifically you can say that it's a circle. So let's try one. I'm going to give you the following equation. We're going to go through the discriminant and talk about how to find what it is. Okay, so here are all the pieces you need. They're not necessarily going to be given to you in order, but you just need to know what piece is what. So we're going to set up the discriminant, b squared minus 4ac. So b is whatever's attached to the xy term, which is right here. So we've got a 2, and we square that, minus 4 times a. A is attached to the x squared term, so that's this number, 3. And c is attached to the y squared term. So don't forget to keep the sign with it. So that'll be a negative 5. Okay, so 2 squared is 4, and then we have 4 times 3, which is 12, times negative 5, which would be negative 60. It's like this. So it comes out to be 64. So because it's a positive number, that makes this a hyperbola. So you do the discriminant, you show all your work for that, and then your final answer would just be telling me what the shape is. So this one is a hyperbola. All right, so down to our last section. Our last section was 9-7. It was solving different systems of equations. So the first one we did was solving equations. In equations, we could either do the substitution method or the elimination method. So I'm going to show you an example of both. And then the very last thing we do will be the inequalities with the shading and everything like that. Okay, so if you saw something like this one would be a really good candidate for elimination. The reason is because we've got y squareds in both and x squareds in both. So you can really easily get them to eliminate. So what I'm going to recommend that we do here is we multiply this whole bottom equation by 2. Because if we do that, this will be a 2x squared. This is a negative 2x squared. They'll just cancel out. So this new equation, when I multiply everything by 2, will look like this. Okay, so now let's combine these up. So combine these, y squared and 6y squared gives me 7y squared. These will now cancel each other out, which is good. And then I add these together and I get 112. Okay, so that's going to help me find my y value. Once I find my y value, I'll be able to substitute back in for my x value. So I divide both sides by 7. When I have 112 and divide it by 7, I end up with 16. So I've got y squared equals 16. So last step, this is super important to make sure you remember this. Whenever you square root a number, you always include a plus or minus. So that means my ordered pairs could either have a y value of positive 4 or negative 4. So I'm going to plug both of them back in. So if I plug in y equals positive 4 versus negative 4, let's see what answers I come up with. So I can plug it just right into this first equation. So positive 4 squared is 16 minus 2x squared equals 8. So I'm going to simplify that. I'll subtract this 16 from both sides. So I have negative 2x squared equals negative 8. Divide by negative 2. So I get x squared equals 4. And then same thing when we square root here. Square root, don't forget your plus or minus. Okay, so with 4, I could either have a positive 2 or a negative 2. So I could have positive 2 with 4, or I could have negative 2 with 4. So there's 2 ordered pairs already. Let's see what I get when I plug in the negative 4. So if I plug in negative 4 and square it, I still get 16 minus 2x squared equals 8. So look at this equation is identical to this equation. So I know if I follow the exact same steps, I'm going to end up with the exact same answers. So with the negative 4, I have 2 different x values as well. So I could pair positive 2 with negative 4 or negative 2 with negative 4. So I end up with 4 different possibilities for that equation. Okay, so that's the elimination method. I'm going to give you a different example that we would use the substitution method for. So that way you get exposure to both. Okay, so this one would be a substitution method. Notice you've got an x squared, but just an x. Y and y we could eventually get to eliminate. So this one you potentially could make elimination work, but I'm just going to show you guys what the substitution method looks like. So this equation right here tells me that y can be written as 2x minus or plus 1. So what we're going to do is we're going to rewrite this y as 2x plus 1. Okay, so I'm going to show you what that looks like. I'm just going to rewrite this top equation. So x squared plus 3x, that part is not changing, equals negative 4, and then instead of y, I'm going to sub this in, and then carry on with the minus 2. Okay, so all x's, I'm just going to start simplifying this up and see what my equation will give me. So distribute this negative 4. And then since this is a quadratic, I'm going to solve by factoring, so I'm going to end up moving everything to the left-hand side. So if I subtract this 8x from both sides, I will have negative 5x over here. And this is a negative 6, so if I add the 6, I'll have this over here. Okay, so that's a quadratic. So like I said, I'm going to solve by factoring. So start with x times x. So I want to multiply to a positive 6 and add to a negative 5. So that would be negative 2 and negative 3. So 2 different possibilities for x. I could have x equals 2. I could have x equals 3. So with substitution, this last step is actually super easy because notice this equation is already solved for y. So I can just plug in my x value. So I have y equals negative 2 times 2, which would be negative 4 plus 1. So that gives me negative 3. So my first ordered pair would be 2 for x, negative 3 for y. Next, if I plug in the 3, I have y equals negative 2 times 3, which is negative 6 plus 1. And that is negative 5. So my second ordered pair would be 3 for x and negative 5 for y. So 2 different intersection points this time. Remember, you can have 0, 1, 2, 3, or 4 total ordered pairs, any of those options. All right, very last problem we're going to do. This is a system of inequalities from 9.7b. Okay, so let's identify what each one of these are. We can get some identifying features and then figure out how to graph them. All right, so this is a circle. The reason it's a circle is because I have x squared plus y squared, so it's not a parabola. It's not a hyperbola because of the addition, and the coefficients are the same, which means it's a circle, not just a general ellipse. The plane x squared and plane y squared means it is centered at 0, 0. And this is supposed to be my radius squared. So if I take the square root of that, I get 7. So that's my radius. Last thing you want to answer with these from 9.7 is whether the line is dashed or solid. And this would be a dashed line, and that's because I just have a less than, I don't have a less than or equal to. And finally, our last check, we could do our 0, 0 check. So if we plug 0 plus 0, it is less than 49. So 0, 0 check ends up being true. All right, so we'll use that when we plot. So let's do all the same stuff for this. This is going to be a hyperbola because I have x squared minus y squared. So the hyperbola makes it, the subtraction makes it a hyperbola. So I'm just going to write h for hyperbola. This one is also centered at the origin, 0, 0. That's because I don't have parentheses with my x or with my y. This x tells me that I'm going to go left and right 4 units. That's the square root of 16. This y value tells me I'm going to go up and down 2 units. It's the square root of 4. This is going to be a solid line because I do have the or equal to. And finally, let's do our 0, 0 check. this would be 0 minus 0 is greater than 1. That is not true. That is false. So with that one, our 0, 0 check ends up being false. So let's plot all of this information here and see what we end up with. Okay, so circle. It is centered at 0, 0. I have a radius of 7. Okay, it's going to be a dashed circle. Okay, and then the 0, 0 check ended up being true. So what that means is that 0, 0 is part of the shaded region, so I would shade inside my circle. Okay, so we start with that. So that's the first part. Second part is this hyperbola. So we've got the same center. We're going left and right 4 units. Up and down 2. And then I know it's a hyperbola, so I'm going to do that whole box, the line, everything like that. All right, and then put this, those are called the diagonal asymptotes. Okay, one last thing that I did forget to write up here. With hyperbolas, we need to know what kind it is. This one, since the x is first, it's going to be a left and right hyperbola. All right, so that means I'm going to go along these, through this point, and along the other one. Like that. So that's my hyperbola. It was solid because I have the or equal to. And the 0, 0 check turned out to be false. So that means this is not shaded. With hyperbolas, you only have 2 options. You can go right down the middle or on the 2 pieces on the edges. So what that means is that the 2 pieces on the edges are shaded. All right, so remember, what I told you guys is to make sure that you have some sort of way to distinguish that shape, the overlapping shape, distinguish it from the others. So that would be the part that's like on the outside of the hyperbola, but still inside the circle. So the overlap between these two would be this little segment of the circle right here, and then this little segment of the circle right here. All right, guys, so I put together a video that like perfectly corresponds with the questions that you're going to have on the test. So if you had an easy enough time with this video, if you're able to watch it enough to make sure that you understand this stuff, I think you will be perfectly fine on the test. Good luck.